say 1/2 u squared is equal to omega squared over 2 times y squared plus some constant. And I maintain, I can even come in here and clean up the equation a little bit. Does that give me that u2 is equal to omega squared y2 plus c2? Or shall I say, back substituting, replacing u with its alternative name, does that mean y prime squared? Actually, can I write it differently? Can I write it as a dy dx? Is equal to the square root of omega squared y squared plus c2. Can I take another break? I think I was given some initial value conditions. That's right. Because y prime is 0 is 0, when I plug 0 in for y and plugs, I misspoke, didn't I?
Plug y.
If x is equal to 0, somebody help me with this. What's y prime?
0.
I'm walking too fast again. What's another name for y?
U.
I heard that. Somebody said a. That simply allows me to dive in and solve for c2. I can do it. What does that mean? Anybody?
Negative omega squared, b squared.
I'll put it in and rewrite. So rewriting, I guess that means dy dx is nothing more than the square root of omega squared y squared minus omega squared a squared. But that just simply says that dy dx is equal to a times, did I misspeak? Sorry, I meant omega times y squared minus a squared. Ah, shoot, how do I solve for y? Integrate. Well, I can't
Couldn't
integrate
you
that.
just-
You mean
You could do separation of variables.
separation of
there, right?
variables technique.
Yeah.
I think I got the integral of 1 over the square root of y squared minus a squared with respect to y being equal to omega times the integral of 1 with respect to x. How are you going to finish? How are you going to finish?
Yeah, he
I do
did.
some tricks though.
Yeah.
You probably dive in on the left-hand side and allow y to be a I can hear you.
Yeah, it should be secant, right? Or a secant.
Theta.
Theta.
Very nice. I agree.
I just have a question. On the top lines where you start replacing the variables, why did you choose to mix the initial value conditions?
What a good question. It's because if you notice this equation does not involve any x's. However, I gotta confess, if I choose a value of x like 7, then when I plug in for y over here is, oh, I have no clue. But if I choose x to be 0, I've got another name for y and y prime. When x is 0, y prime is this, and y is equal to that. I got lucky. It's because these two initial value conditions both have the same x value. And if they had a different x value, I could not have played that game. That was subtle. I was hoping you'd catch that. You guys okay? Can I stop there? Whoever asked, is it okay if I stop?
Mhm.
You see where to go now.
Yeah.
Now, do you feel better about everything?
Well,
You know, when I sit down and write, when I sat down and wrote your exam, it's like I don't feel like we covered very much.
it seems like the majority of the stuff we covered this week.
Yeah.
That's it's always nice to have like a weekend to like study everything, but
You know, it's more like we learned some techniques before this week, and this week we learned techniques involving those substitution techniques Bernoulli and homogeneous. But in the end, those transform into what we studied the past couple weeks.
Yeah.
First order linear, inseparable. So
Yeah.
I think the new techniques incorporate what we did in the past.
Yes.
Exact, maybe a little new, but at least for you Math 32 graduates, old business. And then again, with the higher order DEs, the second order DEs, and special cases, those always transform to first orders that we've been solving along anyways. So I don't think it's that much an extension, or in addition to what we did the previous 2 weeks. But you know, it's the first 2 weeks of the semester, they're introductory.
yeah.
So,
So,
yes.
so just when you have a second order DE like this, your strategy involves substituting u for y prime. That way you
Every time in the 2 cases. The only thing that's gonna change in the two cases, whether you're missing a dependent or independent, is how you're gonna represent the second derivative. That's the only difference. And that is so ridiculously limited, and we won't be this nearly limited after we discuss our linear algebra business. Okay. Anybody else? Can I talk a little bit about linear algebra? Or introduction?